On a surface that is spherical, a triangle has more than 180 degrees. It must have more than 180 degrees. If you look
line of sight, if you've got three straight lines joining 3 points, then that's going to sum to 180.
All right, so big rocks, 50 degrees, 46 minutes, 43.96 seconds. That's the angle between Sims and Cole. That's the other 2 points, right? So they measured to Sims, they measured to Cole from Big Rock. So they got that angle. Then they went to Sims and they measured their angle between Big Rocks and Cole. Then they went to Cole and measured the angle between Big Rocks and Sims, right? Now, here's the cool thing. On a flat surface, every triangle measures 180 degrees. On a sphere, every triangle measures more than 180 degrees. It's an absolute necessity. So if these added up to 180 exactly, Earth's flat. If they measure more than 180, Earth is not flat. All of these more than 180 degrees.
But if we look down the page, we see, for example, triangle 2, triangle 3, and triangle 5 add up to a little bit less than 180 degrees.
The margin of error of all of these is the same. And you can see over and over and over again, these triangles all have a spherical excess. Now, here's the cool thing. All of these more than 180 degrees.
Less than 180 degrees.
And never do flat earthers ever take into account the details, right? They just say, well, it must have been from a certain level, but it's not. It's always wrong. Get your details right before you start talking about stuff. It seems like you are convinced by lack of detail and lack of critical thinking on how to actually analyze stuff.
So we're going to look at the detail. So the first column is degrees, and the second column is arc minutes, 60 arc minutes in a degree. The third column is arc seconds, 3,600 arc seconds in a degree. Fourth column is hundredths of arc seconds. So we're just going to look at the arc seconds, and we get 120, so that's 2 arc minutes. So then that gives us 60 arc minutes, which is 1 degree. So 179 degrees plus 1 degree is 180 degrees. So that puts the excess in the 36 thousandths of a degree. So we look at another one, and we only have 58 arc minutes. So we'll go into the hundredths column on this one to get the 2 extra arc seconds that we need to come up with the extra arc minute, to come up with the 120 arc minutes to get the 2 extra degrees. So it's a reoccurring thing. The excess is in the 30, if there even is excess, because a lot of them have less than 180 degrees. It's a reoccurring theme here. Look, we wind up short on the degrees and short on the minutes and short on the seconds. You add it all up, it's a joke because the margin of error is magnitudes greater than these measurements. They're not measuring excess. So pt.Toon has said on multiple occasions, every time he's asked for proof of curvature measurements, this is his go-to. So did he even look at the detail? And if he did look at the detail, then he pulled up a page with no measurements less than 180 degrees. Now, take it, at least the guy on Flatzoid's channel was honest enough to show the multiple measurements that come up under 180 degrees. So pt.Toon is either a hypocrite or a liar. Take your pick. And all these other ballers, anti-flat earthers, are going around parroting him. At least the one guy was honest enough. And on top of all that, the margin of error way outweighs the measured spherical excess.
So the question is, how do you initially come up with the radius for the Earth to even compare it to the mathematics that you get from those spherical triangle surveying experiments that you identified earlier? So you're talking about the example that you used before with your spherical triangles, and when you said, and you do this measurement at these different locations, 6, 7, or 8 locations, and when you do those, it comes out, and the measured radius or the factored radius, the calculated radius, matches what we expect to see of the Earth. That it is exactly or close to what the model predicts. The problem is that the radius that the model predicts is itself an assumption.
No, you didn't pay attention to what I said. None of my presentation had any assumptions about the shape of the Earth. I assume nothing. Nothing at all.
Look, it's even worse than I figured earlier. The spherical excess is in the 5th decimal place. So it's in the hundredths of thousandths column. So the first is tenths, the second is hundredths, the third is thousandths, the fourth is 10 thousandths, and the fifth is hundreds of thousandths. So the spherical excess is in the hundreds of thousandths column. And you think they're measuring that. The the margin of error is magnitudes greater than that, like I said. And I got one other important thing to point out here in a second.
These triangles, these spherical triangles were measured. They were more than 180 degrees, every single one of them. That absolutely defeats the possibility that the surface of the Earth could be flat. No question about it, because they're not 180 degrees. Every one of them is more than 180 degrees.
But if we look down the page, we see, for example, triangle 2, triangle 3, and triangle 5 add up to a little bit less than 180 degrees.
Every one of them, when you add up the degrees in the triangle, add to more than 180 degrees.
Less than 180 degrees.
So Zanik, if you've got a triangle, it doesn't matter what the altitudes are. If you've got a triangle in 3D space and there's a lot of straight lines joining the vertices, that's a coplanar triangle, and those the sum must be 180 degrees.
And it's just the left-right. It's not the vertical measurement. So you don't the topography doesn't change it. You just get the left to right.
So I guess I take some issue with that, because even at 100 kilometers, which is what, around 60 miles or so, there is no curvature obstructing the view from each theodolite to itself, just while they're taking the measurement.
They're measuring a triangle, a horizontal.
But they're
triangle.
Still made up of 3 straight lines, right? Like connecting each other.
Line of sight, if you've got 3 straight lines joining 3 points, then that's going to sum to 180. But
right.
Please address the actual evidence. They're on mountaintops or hilltops or on a tall structure that they built. There's nothing in the way.
I don't know what to say, man. I don't know what to say. It seems like such circular logic.
Maybe you should actually do some research on your own.
Yeah.
These things have been done for centuries, right? You didn't know about it because your Papa Flurf didn't tell you about it.
Look at this psychopath.
You didn't know about it because your Papa Flurf didn't tell you about it.
One last thing. Look at the column next to the green box, the row where it says corrections. For every single measurement, they had corrections. Now, what are they correcting for? I thought there was no refraction. Remember, it was the one guy's favorite proof because there's no refraction. So what are they correcting for? Okay, I'll tell you what they're correcting for. They're correcting for their model. This is a case, again, of using their model to prove their model. It's ridiculous. So if you have 3 lines of sight, then you have 3 straight lines point to point. So they're not talking about the triangles themselves. They're talking about the ground underneath. So they're using their model to try and prove their model. It's ridiculous.